Welcome back. In this lecture, we will first define what are the characteristics of a vehicle for it to be called a full hybrid electric vehicle. And we will also discuss how the battery is integrated into this system. For a hybrid vehicle to be called a full hybrid vehicle, these features have to be present. First, there should be regenerative braking. So, this is a very interesting piece of technology that significantly improves the efficiency. Supposing a vehicle has to be stopped. So, there is this decrease in kinetic energy of the vehicle. Typically, in a very conventional vehicle, the way to brake is you apply the brake, then the kinetic energy of the vehicle gets converted into heat energy via friction, right? So that is the way you're used to stopping the vehicle. However, when regenerative braking is integrated into the vehicle, the decrease in kinetic energy of the vehicle during braking is used for recharging the battery. So we are not going into the details of how this technology is implemented, but overall, the goal of regenerative braking is that instead of wasting the kinetic energy of the vehicle during braking, it is used for recharging the batteries. Then the batteries also are important for propelling the vehicle in a full hybrid vehicle. This can be implemented via the series or parallel hybrid architecture introduced in an earlier lecture. So, to understand this, you have to contrast the architecture, that is the series and parallel hybrid architecture, against the stop start hybrid architecture. In this architecture, the rechargeable energy storage system go towards running the accessories and the starting of the car. But in this architecture, the batteries help to propel the vehicle. So this is quite efficient, but what is the trade-off? The trade-off is the complexity of operation increases, and because the battery size also increases, it adds to the cost of the hybrid vehicles. Why are the hybrid vehicles efficient is because of a feature we have already discussed in an earlier lecture. In this lecture, we mentioned that the internal combustion engine operates at the lowest fuel consumption in a very, very narrow region. Only in this region, plotted against velocity and the power provided by the engine, only in this narrow region, the internal combustion engine is most efficient because it has the least specific fuel consumption. So if you want to operate at different speeds, the efficiency goes down and the fuel consumption increases. Because of this feature, we want to augment uh, power from the fuel internal combustion engine by burning the fuel with power from a rechargeable energy storage system. So this can be done if the engine operation is completely decoupled from the vehicle speed, not completely, if it can be decoupled. Okay. So irrespective of the vehicle speed, if the engine can operate in under condition where it is most efficient, then hybrid in that scenario, hybrid vehicles become most efficient in the sense that the internal combustion engine operates only in this narrow window where it's most efficient, where it consumes the least amount of fuel. But all the other power requirement is met in some other manner. As opposed to internal combustion engine, batteries, capacitors, and electrical motors have a broader operational window wherein they are fairly efficient. So this is another crucial feature that has to be appreciated to understand why hybrid vehicles are more efficient than just operating a vehicle via internal combustion engine. So let us look at parallel hybrid. This architecture has been introduced earlier. What we are plotting here is, let's say a vehicle is running, as a function of time, we are plotting the power requirement of the vehicle. Typically, the vehicle stops, starts, goes at different velocities. Therefore, its power requirement keeps changing. Let us focus the power requirement in under certain condition. So in this curve, we are plotting the total power that is required out of the system. The engine has a maximum power that it can supply, that is, let's say 10 kilowatts. If you need more power, okay, beyond 10 kilowatt, this additional power is provided by the battery. So the battery provides additional power. So this minus this is the power that is supplied by the battery. So the engine size is also fixed based on the maximum power it can supply. Any additional power beyond this is supplied by the battery. So let's look at another phase, this particular phase. So the power requirement is less than power requirement of the vehicle is less than that what can be supplied by the engine. So the engine can supply this much amount of power, but the vehicle requires lesser power than this. But the engine operates at power more than the total power required by the vehicle, running the vehicle, because this additional power, this minus this, goes towards charging the battery. So this much amount of power goes towards running the vehicle. This minus this goes towards charging the batteries. So whenever this is in negative, that means that the battery is getting charged. So here the battery power is positive. That means the battery is providing the power. In this case, it is below zero. That means the battery is getting recharged. That is, the power is dumped inside the battery. So we can also look at additional features here. In this phase, the power requirement of the vehicle is decreasing. That is, let's say you're braking the battery, by braking the vehicle. So in this case, the kinetic energy of the vehicle keeps coming down. In this phase, the regenerative braking technology can be utilized for charging the battery. Again, the battery, this number goes negative. That means the battery is getting recharged, and that is because of the regenerative braking technology. So this is the way it is implemented in the parallel hybrid. Just to, as a reminder, a parallel hybrid is one wherein there are two ways of running the vehicle. One is via combusting the fuel in an internal combustion engine. If there is more power that is required beyond the engine capacity, this additional power is provided by the rechargeable energy storage system. So the decoupling of the engine operation from the power requirement of the vehicle can also be done in a series hybrid architecture. If you remember, in this architecture, the fuel combustion goes towards operating the engine, which goes towards operating a generator. This generator not only can supply power for running the vehicle, it can also supply power for charging the battery as well as for operating the auxiliary loads. So the engine may operate at a window wherein it's most efficient. So this power requirement is decoupled from the power that can be supplied by the engine because additional power can be supplied um, via battery too. So in the next lecture, we will look at some ways we operate the battery in a hybrid electric vehicle. Thank you.